Hey guys, welcome back to the Black Hills and Eastern Railroad. It's been a couple of days since I released that switch machine crossover indicator LED light accent light video, and there's been a couple of questions over how I did that here, and I wanted to clarify and give a little bit of additional information as to how I did that, and maybe go over some things that I left out in that original video.
Black Hills and Eastern Railroad, from the plains of the Sioux Empire to the heart of the hills.
So a viewer, Colin, asked here about this schematic or some kind of documentation on how exactly I hooked everything up on the LED indicated crossover switch. And I wanted to provide some additional understanding here. The diagram that I referenced to Colin originally was not fully correct in how I'm doing things now. It may work, but it probably does work actually. I studied it a little bit, but it is not exactly the way I'm wiring things here now. Um, so I wanted to go over, and there's a couple other questions regarding dropping resistors and accessory inputs, outputs on the Tortoise machine. But I wanted to go over that to make sure that I clear up all the misunderstandings. And also, I will link to a series of videos that I put out on doing these panels and stuff. Hopefully, you find that helpful if you're interested in the doing the artwork side of things. If you missed that, that's for reference down in the description below. And so we'll get started here on this schematic. The 12-volt DC power supply is what we start with, a wall wart, and this will be important here in a couple of weeks. I've got another episode talking specifically about that power supply. That's just a wall wart that I got out of some other set. In fact, I think this one came off an estate. But the DC part is important here. The Tortoise machine, you won't blow one up using 12 volts AC, but it just won't work. So you want DC output 12 volts, and I think the one that we're using here is half an amp, 500 milliamps. So just for reference, what we're doing, that seemed to work fine. So if you can find one of those, I don't know, toy charger, whatever you might find out there. Certainly, you don't have to go out and spend a bunch of money, and most people have a box of these things sitting around the house. So what I did is I inputted these into the middle terminals, the middle two terminals on the DPDT switch, um, soldered those in, and that's how those are. Then the important part here is on the DPDT switch is you want also always constant power going to the Tortoise, but you're going to reverse that. So effectively, you have your power coming in here, and either you have it coming out on the left side of the switch here or the right side, but you want it reversed based on how the switch is thrown. And I've kind of drawn this a little oddly, but I wanted it to be known that here's your switch and here's your switch human interface piece on top. So we have the crosswire here from this terminal to this terminal, and then the other wire coming from this terminal to this terminal, and then we have wires going out from the DPDT switch, and these are these switch polarity depending on the position of the switch to terminals 1 and 8 on the Tortoise machine. Then, with regard to, and some people, and that's what I showed on this video. But if you wanted to move into powering the frog on the Tortoise, excuse me, on the switch itself, you would be wiring off of the pins 2 and 4 and 5. So 4 and 5 come in from the DCC or DC track bus. This will work just the same, just as well for DC or DCC. So again, track power in on pins 4 and 5, and then out. And typically it doesn't matter to me, but I kind of as a standardized setup here is using the green wire coming out from pin 2 and going to the switch frog. So that gives you continuity over the frog for your shorter wheelbase locomotives. I haven't done that on all these switches here, and I probably won't. So let's go over to the layout real quick, and I'll show you a close-up view of what this actually looks like in practice installation. So I have here the DPDT switch that I'm using standard basically on the layout here on these switch control panels. And I wanted to show you some more detail about how I do these. I got these DPDT switches off of allelectronics.com before they folded. We'll have to find another source of these next time it's time to order, which won't be that long from now because I am running out of these things. In any case, I showed you that we're bringing power into the middle two poles. That's from your 12 volt DC power supply. And then it's important to note here that so we're going to describe this as the top, basically the top left pole and the top right, bottom left and bottom right. So we are going to be soldering a jumper from the top left here to the bottom right, and then the same thing, basically the converse with the top right to the bottom left. So that basically gives you power going out on both sides. So then it's your choice whether you want to solder the top or the bottom out to your Tortoise switch machine with your LEDs, if you so choose, in line with that. And I've just been using real light gauge wire with this. Not much is required. In fact, a lot of guys report having success with Cat 5e, and I had some scrap left over here, so that's what I'm using, a little bit of that. And the rest of it, I guess, is what they call alarm wire. So then with regard to the switch position indicator lights on the panel, as I described in that video, we've got power coming out from the DPDT switches, going to pins 1 and 8, and then soldered. In series with that pin 8 wire, I've got bipolar 5mm LEDs. I did not see the need to solder any kind of dropping resistor in line with those. We've got the proper current in here and making these things work just fine. The interesting thing about bipolar LEDs is they're essentially two LEDs in one, and those of you that know about LEDs know that they only work with current going through them one direction. If you switch the polarity, they just won't work. They won't blow up, but they don't work. But essentially with the cathode and anode switching in the same device here, it depends on which direction you've got power going through, depends on which color the LED is illuminated in. So either get red or green depending on how the power is going. The important part to understand with this installation though is that we're opposing the legs on this. So either you're soldering the short legs together or the long legs together. Doesn't really matter what you do. Maybe as long as you're doing it consistently across all of your installations on your layout. So basically, you get opposite colors here with the same power going the same direction in that circuit. And again, I didn't feel it necessary, or I didn't see the need to put any dropping resistors here with any of this. So this is just the bare bipolar 5mm LED. So in the description below, I'll put a link to this diagram that I've showed you here, a little higher resolution than you're able to get off the screen. Just in case you've got any questions, and if you have any questions that I haven't answered here, feel free to ask them either on that Facebook page or right here in the comments below. And I hope you enjoyed the content here. I'm not the expert, but I'm just documenting the way I'm walking through building this layout. Hopefully it served you well. If it did, smash that like button, subscribe for more, and hopefully I'll see you guys in the next one. Bye, guys.